What's electric? Alright, okay. Alright, our first part of our section, our whole thing was on power. First thing was on currents, which they kind of did. We got alternating current and we got direct current. AC/DC, that's where they got the name. Potential difference is the difference between potential energies, which allows for charges to move from the higher concentration of the energy to the lower one. This allows for a current to occur, which is prominent in circuits, which powers the items within the circuit. Think of like when you're trying to heat water, how the heat transfers from your flame into the water. Same kind of idea, goes from a hotter surface to a colder one. The one with the higher heat transfers to the one with the lower heat. Same concept. Direct current moves in only one direction. The negative charges within that are flowing from them, they move from lower to the higher potential. Okay, that's not right. They move from higher to lower. That's mixed up. And actually, electricity flows the other way. Electricity, when the electrons move through, the electricity flows the other way. Alternating currents are constantly changing sign. Since there is no set motion of the charge, they just vibrate back and forth. This can, apparently this causes when you have flashlights or bulbs, they will alternate and they will flicker. So what they do is they change the oscillation to be really fast. That way you don't really notice it.
So that your eyes can't pick it up.
Yeah.
What was the standard numerical on
60 kilohertz, I think.
Kilohertz was the standard.
And that's the frequency of
which the
going back and
current
forth.
changes. Okay. Energy transfer. Batteries are basically chemical energy, you know, the alkaline. It basically converts it into electric. It's supposed to be convert, not close. Basically, the collisions within the charge carriers and the other particles of conductors causes the electrical energy to become internally, or when those electrons move through, they bounce into each other, and that causes energy. Yeah, they just don't look at each other. It's like a massive wash thing.
Resistor causes electrical potential energy to lower. That causes more collisions of electrical. Batteries' chemical energy is decreased by Q, or charge on a symbol. It's multiplied by the change in V, which is a potential difference. The same equation you guys had in the other ones, and replaces lost electrical potential energy. Potential energy is increased by Q times change in V.
That's just basically the opposite. When you have the potential energy, it's got to be increased because it's losing some through the resistor. That's how it's creating electricity, is the change from potential to actual energy. Alright, here are some of our terms. You all know electrical power, that's in watts. And our equations can be recognized as P, and our unit is W. Potential energy is change in PE, and that's in joules. The potential difference is the change in V, which is volts. Current, or I, is amperes or amps, which is A. Charge is Q, which is in coulombs. Time is change in time, which is in seconds. And resistance is R, which is in omega. Alright, here are some of the equations. All of these are for power. We got, the first one is power is the change in potential energy divided by the change in time. We got the power is the charge times the change in potential difference divided by time. You got power is the current times the change in the potential difference. You got power is the current squared, it's supposed to be times the resistance, or power is potential difference squared divided by resistance. The equation for potential difference is change in V is change in potential energy divided by the charge. And the equation for potential energy is Q times potential difference.
So there's a lot of different ways of thinking of power and calculating power.
Yeah, and if you look at it, the potential energy, you can take this stuff and plug it in. Like back here, if you know these ones, you can take what you do know and plug them in.
What's the main one going to be?
For our equation, we use all of them, but the main one is usually going to be this Y. or resistance. When do these three are all together? They're basically
This, you can pretty much derive any one of these
from each other.
Yeah.
Can I interject something? Outside of electricity, a general one is going to be the energy, so the potential energy there, divided by the change in time, or work divided by change in time. So the change in energy is work, and then if we take that over time, that gives you power. So in whatever type of energy you're looking at, or whatever type of power you're trying to look at, it's going to be the energy divided by time that's going to cross that's going to cross the different fields of physics.
Okay.
So power is work divided by time.
Only thing with the electric, the reason why I said it was these ones is because with the electric there's a lot less, I want to say, time intervals kind of thing. So
Yeah. Right, and I was just saying the one that's going to, the cross between your different topics is going to be the work divided by time. And that'll help you get your other formulas.
Okay, so like she's saying, this is really important about this.
No. I'm just saying, you told me the one for the electrical, that's fine. To help you go from electrical energy to mechanical energy to gravitational energy, it's always going to be your energy divided by time to get you the power. If you're going between different types.
There's this extra section at the very end that basically it kind of was like real world application. The electric companies, they charge by kilowatt hours. In terms of joules, which can be described as watts times the seconds, which is power times seconds. It factors down to 1 kilowatt watt per hour, and then that's just the metric conversion. Gets you 3.6 times 10 to the 6 joules. And if you think about it, watts times seconds, that goes back to our potential energy equals power times time. Basically, to get to the joules, we have P equals change in potential energy over time, times it over here. Power of time would equal change in potential energy. So watts per second equals joules.
And then you'll multiply that by the rate of money you're paying. That'll be how much you owe for so much.
Okay. Okay, so the batteries, they give out a potential difference of 3 volts. And we actually have 2 resistances. We have the light bulb holder, which is R1, and we have the light bulb itself, which is R2, which is, those are the resistances.
How do you know that?
Because they actually say it on them.
Oh, they do?
Okay, I was gonna say, where'd you get this from?
Okay.
Okay, so they actually give us that information. And then if you plug it into our equation, this is how much power is going through the light bulb holder is 0.75 watts. And how much power is going through the actual light bulb itself, because it's a little bit of higher resistance, is 0.73 watts.
And it lights.
And it's also a closed circuit, that's how the current passes through.